Good day, students. Welcome to a review series on the graphing of trig functions. In this installment, we're going to be going over how to graph and fully analyze the secant, cosecant, cosine, and sine curves. All right, so let's take a look at the instructions. We're to graph the following functions on the specified domain and analyze fully. So for number one, we have y equals sine x, and we're going to graph it on the domain negative pi over 2 all the way to 2 pi. Okay? Alright, let's go ahead and set up our coordinate system through our x and our y-axis. So we have our y-axis and then our x-axis. Alright, so in this case, the amplitude is 1. There's an invisible 1 here, so we can count, let's call 3 units 1. Okay? 1 unit to the max, 1, 2, 3, negative 1 to the min. Alright? So let's go ahead and we're going to go ahead and draw in our maximum and minimum displacements from the central position. So this is my maximum displacement right here. And this is my minimum displacement from the central position. Since this is a parent trig function, we're going to calibrate using our axis coordinates. So we'll start with the negative component, negative pi over 2, which is like 90 degrees. And then we have pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, I went as far back as negative pi over 2 because that is what is indicated in my domain for graphing. So what is the orientation of the points of your sine curve? So recall how the sine and cosine curve look, right? So let's do a real quick refresher. For sine, the sine curve is like an S. To the right is like an S going up like this. And then to the left it goes down like that. So that's a positive sine curve. What if you have a negative sine curve? If you have a negative sine curve, the orientation is a reflection of this along the x-axis. So it goes down to the right and up to the left. Let's do that again. Down to the right and up to the left. Something like that. All right. And how about our cosine curve? Our cosine curve basically looks like a cup. So for positive cosine, the orientation starts from the maximum and looks something like this to the left and to the right. The negative cosine is a reflection of this along the x-axis. Looks similar, but it's reflected. In this case, you start from the minimum, looking like an inverted cup. So that goes the orientation for your negative cosine. Okay? Alright, so we're going to use these points as a guideline for generating our curves. So let's start with number 1. We're looking at positive sine. So we note that for positive sine, we're going to start from the center. Okay, let me use a different color. You start from the center. If it's positive, you're going to go up to the right, down to the left. Okay, so we're going to go next tick mark maximum, next tick mark center, min, back to the center. So we follow this pattern in eternity, but for an eternity, but this interval asks us to restrict our graph to negative pi over 2 to 2 pi. And if we go to the left part, we just go down to pi over negative pi over 2. Okay? So if we connect our dots, that will be the graph of the sine function on this specified domain. Alright, so concave out of the min towards the center, and then concave up out of the min towards the center, and then concave down from the center to the max, concave down from the max to the center, and then concave up from the center to the min, and then concave up from the min back to the center. Alright, so that goes your sine curve on the specified domain. These brackets mean that our starting and ending points are closed circles. Alright, they're included in the graph of our solution set. So there you have it. Now let's analyze this fully. let's talk about increasing and decreasing first. So where is this function increasing on this domain? Is increasing when you go from left to right if you're heading upwards. So we notice that we're increasing from negative pi over 2 all the way to pi over 2. And then another interval where it's increasing is from 3 pi over 2 all the way to 2 pi. Okay? And then decreasing. Where is this function decreasing? Heading down from left to right is from pi over 2 to 3 pi over 2. All right, so from pi over 2 to 3 pi over 2. All right, next let's look at the max and the min, the maximum and the minimum. Maximum is the highest point, the highest value that this function attains and where it happens at. So we have a um, maximum at x equals pi over 2 gives us a maximum output at x equals pi over 2, and the value is y equals positive 1. Okay? Now let's look at our minimum. What is our minimum value on this point, and where does it occur? It attains its minimum of negative 1 at negative pi over 2 and 3 pi over 2. So at x equals negative pi over 2 and 3 pi over 2, it attains its minimum value of y equals negative 1. Alright, so there goes your minimum value. Alright, let's take a look at the concavity. This function is concave up, concave up, wherever you have a complete U or a partial U facing upwards. Here we have a partial U facing upwards, so it's concave up from negative pi over 2 all the way to 0. And then you also have another interval where you have an upward opening or facing U, which is from pi to 2 pi. Okay? Next interval is where we have a downward facing concavity, the interval where our function is concave down. We have only one interval where we have a downward facing concavity, and that is from 0 all the way to pi. Alright, so that's that. Let's take a look at question number 2. For number 2, we have to graph y equals negative 3 cosine x on the interval pi to 2 pi. Okay? Let's set up our coordinate system. It goes our y-axis, and then our x-axis. Let's label them. This is x, and this is y. Let's call this our max. 3 units up and 3 units down our min. Now, since the amplitude is 3, 3 and negative 3 will be our max and minimum displacement from the central position. So let's go ahead and indicate the boundaries for our max and min for the cosine curve. Looks something like that, maximum and minimum. Now the calibration is as follows. We're going to go from pi over 2, that's pi over 2, to pi, to 3 pi over 2, to 2 pi. Okay, now to graph negative cosine, the question is, where do we start? This interval tells us where to connect. It doesn't help us orient our points. So the first thing we're going to do is orient our points with this interval inclusive, and then we connect it using this domain specification. All right, so always start your points from the y-axis to orient yourselves. Where does cosine start from? Cosine starts from the max if positive, but this is negative, so it starts from the min. So we go from minimum to center, to max, to center, to min. Okay? The reason why we have a point here at 0 is just to help orient our point at pi all the way to 2 pi. Without this point, we won't know where to put the point at x equals pi. So now that we have our points oriented, now we can just simply connect them on the specified domain. So we'll have concave down from the max to the center, and then from the center to the minimum, concave up. And that goes your final answer. Since you have brackets here, our endpoints are included in our solution region. So that goes your cosine curve. Let's go ahead and analyze this. It's increasing. Where is it going upwards from left to right? Or no interval, so none. Decreasing is decreasing on the entire interval on this graph, so it's decreasing from pi all the way to 2 pi. Let's talk about maximum. The maximum. The maximum is at x equals pi, and the value, maximum value is 3. Okay? The minimum is at x equals, this is the low point here of the graph, x equals 2 pi, and the value is negative 3. Now let's look at the concavity, concave up. Where is this concave up? Where do we have a complete or partial u? We have a partial u facing up from 3 pi over 2 all the way to 2 pi. And then we have a downward facing concavity from pi to 3 pi over 2. All right, so that's that. Now let's take a look at question number 3. So for 3, we have to graph y is equal to 2 cosecant x on the interval pi over 2 all the way to 2 pi, with 2 pi being included in the domain. All right, so let's see how we can graph this. This is an asymptotic trig function. So in order to generate the accurate cosecant curve, we must draw the related reciprocal identity of it. All right, so we know that cosecant, or we can say 2 cosecant x, is equal to 1 over 2 sine x. Okay, so cosecant is the reciprocal identity to sine. All right, so this is the relationship right here. All right, quick correction right here. For the identity, there isn't a coefficient, so let's take this 2 out of there. So cosecant x is equal to 1 over 2 sine x. All right, so that's that. So let's set up our coordinate system, our x and y axis. So there goes our y axis. All right, so there goes the x axis. And then let's put in our max and min. For this, we're going to be graphing 2 sine x first. So our maximum is going to be 2, and our min, 1, 2, 3, is negative 2. Because of this 2 we have here, let's go ahead and indicate our max and min position for the related reciprocal function. So there's the max and there's the min. All right, let's go ahead and set up our calibration. So we have pi over 2, pi over 2, this is pi, 3 pi over 2, and 2 pi. Okay? All right, so we're graphing sine. We know where sine starts from. Sine starts from the center, and then to the max, to the center, to the min, back to the center. Okay? Let's go ahead and sketch the sine curve. We're going to be going from pi over 2 to 2 pi. All right? So this will be broken. We're going to make it dotted. The reason why it's dotted is because this is not what we are asked to graph. We are just creating the function that helps us determine where the asymptotes are for our cosecant function. All right, so I'm going to use dotted lines here. So there goes the related reciprocal function. Now this tells me where the asymptotes are at. The asymptotes occur when a function has a 0 in its denominator, and that happens when sine x is 0. So sine x is 0 at this point and that point. So let's draw our vertical asymptotes on the graph. So there goes the first one. And there goes the second vertical asymptote. Now to draw our cosecant curve, all we'll simply do is we'll take this portion right here. Now this point is not included in our solution region, so we have to make it an open circle. It's not an asymptote, it's an included point, so whether it's included or excluded applies. So make an open circle here, and then we'll reflect this portion up, and there goes your cosecant curve. Let me draw it again. You go really close, concave up towards the asymptote without touching it. Okay, something like that. And then down here, from this point, the minimum, you go down towards the asymptote without touching it. Pattern continues forever, and then this one goes in the other orientation. This black portion right here, that is your cosecant curve. That black one, y equals 2 cosecant x. Now let's do the analysis. Where is it increasing? It's increasing from pi over 2 all the way to pi. And after you jump over the asymptotes, the infinite discontinuity, you're also increasing from pi to 3 pi over 2. How about decreasing? On what interval is it decreasing? It's decreasing only on one interval, which is from 3 pi over 2 all the way to 2 pi. Okay? Our extrema, maximum. This function goes up forever, has no upper bound, no upper limit, so the maximum is none. And then the minimum, it goes down forever as it approaches this asymptote, so there are no minimum values. And again, there are none. Or how about a concavity? Where is it concave up? We have a partial u facing up here, so it's concave up from pi over 2 all the way to pi. And it's concave down on the other interval, which is from pi to 2 pi. All right? So that's that. Now let's take a look at the last example, question number 4. So for problem 4, what if we have y is equal to -4 secant x on the interval -pi all the way to pi. Okay? Now secant, we know secant x is related to cosine by reciprocation. So secant x is equal to 1 over cosine x. This is one of your reciprocal identities. So what we're going to do first is we're going to graph the cosine function, and then we're going to graph the asymptotes and generate our secant function from there. All right, so there goes our axis, our x and y axis. So let's label them. This is our y-axis. This is our x-axis. They both intersect at 0. All right, let's go ahead and indicate our max and min. So let's use 3 marks. 1, 2, 3. That's our max. 1, 2, 3. That's our min. Since there's a 4 here, we're going to go a -4 and 4 for our max and min values. Let's go ahead and graph our boundaries, our maximum and minimum displacement from the central position. So for the parent function, that's what we have. Okay, next thing we're going to do is we're going to go ahead and calibrate our x-axis. So let's use 3 this time. So 1, 2, 3, that's pi over 2. And then 1, 2, 3, that's pi. Going to the left, 1, 2, 3, that's pi over -pi over 2. 1, 2, 3, that's -pi. All right, so there goes our calibration. Now we're graphing negative cosine, so we have to be careful here. When you're graphing negative cosine, you start from the minimum. Okay, positive cosine starts from the max, as we indicated earlier, and negative cosine starts from the min. So we have minimum, center, max to the right, and then center max. Okay. All right, let's go ahead and graph the related cosine function. So concave up to the min, concave down to the max, I meant to say to the center, and then it's going to concave up from this point to 0, and then this is concave down all the way to here. Now let's graph our asymptotes. This is going to be our first vertical asymptote. It is wherever cosine is 0, secant will have an asymptote because it has a 0 in its denominator. And then also on this line we have another vertical asymptote. Alright, now that we have our vertical asymptotes drawn, we can go ahead and construct our secant curves. Alright, so let's graph our secant curve. Now, we need to pay attention to these intervals here since it's included in the graph. The intervals do not fall on asymptotes. Since they are both parentheses, that means our endpoints are excluded. So we're going to have a closed circle here, and then reflecting this portion up, we have a upward facing concavity towards this asymptote. And then here, down here, from this minimum, concave down to this asymptote, and then concave down to this asymptote. And then over here, we have this point, concave up towards this asymptote as it tends towards infinity. Let's draw that portion again. So something like this to that point. So that's that, okay? All right, so this black portion right here, that is our secant curve, okay? So this is for secant x. Let's go ahead and do our analysis. Increasing, where is this function increasing on? This function is increasing on two intervals from negative pi from negative pi to negative 3 pi over 2, where it goes to infinity. And then down here, it's also increasing from negative 3 pi over 2 all the way to, okay, I think I made a mistake here. There's no 3 there, so it's supposed to be pi over 2. Let's fix that real quick. So from negative pi to negative pi over 2, and then from negative pi over 2 all the way to 0. Okay, I thought there was a 3 here, but there isn't. Sorry about that. So it's increasing here and increasing here. Now where is it decreasing? It's decreasing from 0 to pi over 2, and then it's also decreasing from pi over 2 all the way to pi. Now extreme at the max and the min. The maximum, it goes in these two portions right here, it goes up forever to infinity, so there isn't any maximum value for this function. And then a minimum in these two portions here, it goes down forever, so you do not have a minimum. How about our concavity? Concave up, upward facing concavity occurs in these two intervals right here. So from negative pi to negative pi over 2, and then from pi over 2 all the way to pi. Downward facing concavity, only this one interval here from negative pi over 2 all the way to pi over 2, and that's that. Okay? But thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel for other cool updates such as this, and please post a comment to let me know what you think about this presentation. Or please come and find math.serve.com. Thanks again for watching, and have a wonderful day.